Okay, so here we're going to look at some special cases of logarithmic functions. Special cases meaning special choices for the base. And really for us, there's only two special cases. When the base happens to be 10, in that case you get what's called the common logarithm. And that's written this. Now, it's really this case when the base is 10. Generally, though, people don't write the 10, and they just write this. So you might see in the calculator this over here. Actually, let me just erase that. You might see that. And this is just when y equals log of x, exactly when 10 to the y is x. So really, that's just what this means. Another one that's also well known is the natural logarithm. Now that's actually written this way though, as ln. Now with ln, that's when the base is actually that number e, and e again is a special choice of the base for the exponential function. E turns out to be about 2.71. It's a number between 2 and 3, and it's irrational. Again, irrational means you cannot write it as a fraction of two integers. So natural log of x, we have y equals natural log of x for any positive x exactly when e to the y is x. So those are really just the two cases for us. Now here I want to look at special equations that are called logarithmic equations. These are equations that have a logarithm in them. And as a reminder, whenever you have log base a of something, m I'm calling it, the a has to be positive. It can't be 1. And the m also has to be positive. I'm pointing this out again because as you'll see, when you solve these equations, sometimes you'll get what's called an extraneous solution. That solution actually doesn't satisfy the logarithm, and we have to actually discard it. You'll see what I mean when we do some examples. In fact, the first one here is an example of it. We want to figure out what x is here. Okay, so again, really by just doing a log roll, or really just by definition as I wrote, what you have is x squared is equal to 25, which is how I got this equation here. So again, we want to figure out what x is, right? Taking the square root, we get x is either plus or minus the square root of 25, which is plus or minus 5. But again, x has to be positive. Okay, that's what we just said. So the negative 5 we actually throw away because it can't be a solution. In terms of the context of the problem, which is the logarithm, it can't be a solution, so we throw it away. Thus, the only solution here is 5. Here's another example. So again, doing a log roll, let me actually write it out better. We have 5 cubed equals x. So we have 5 cubed equals x. So in this case, we have 5 cubed, which is 125, equals x. Although really, I guess it's better to write it this way. Good. Here's another one. So again, we have log base 7 of x squared plus 4 equal to 2. So again, doing the log roll, 7 squared must equal to the inside. So in other words, we have 7 squared is equal to x squared plus 4. Okay, now we know 7 squared, we'll do that later. We know that 7 squared is 49. So we have 49 is x squared plus 4. Okay, we want to get x, right? So we subtract. Okay, these cancel. We get 45 is x squared. In other words, x squared is equal to 45. So to calculate x, we take square roots. So I'm going to go over here for room. We have x is plus or minus the square root of 45. Now notice here, there are no extraneous solutions. Since we have x squared plus 4, okay, and that's on the inside here, we don't have to disregard negative square root of 45 because we're squaring it. Okay? Because we are squaring it. So that tells us plus or minus the square root of 45, both of these are solutions. Okay, so now what we're going to do is we're going to solve some other equations here. We can actually solve, these are exponential equations, but we can solve these using logarithms. Okay, so over here, for instance, what do we have? We have e to the negative 2x is a third. Okay, so we're going to convert that to a logarithm because we want to figure out what x is. We have logarithm base e of 1 over 3 is minus 2 times x. Now let's check, though, that this is the same as the original equation. How do we check? We do a log roll. E raised to the negative 2x equals a third, right? So e raised to the negative 2x, that's what we have, equals a third. So we do have that. Okay, so we have logarithm correctly. The correct logarithmic statement, excuse me. So we have negative 2 times x is log base e of 1 over 3. So how do we get x? Well, that's easy. You just divide by negative 2. Both sides by that. And again, log base e is actually natural log. So let's take a minute. So we have x is natural log of 1 over 3 over minus 2. Even though I wrote log base e, but that's okay because we're doing a logarithmic roll. So for this one down here, 10 to the 4x, same idea. Here the base is 10. We're going to have log base 10 of 5 is 4x. Now, is this right? Well, let's do a log roll. 10 raised to the 4x equals 5. And yes, that is what we have. So how do we get x? This is easy. We just divide. So we have 4x equals log of 5. Notice I didn't write the base in there because log base 10, you don't have to write 10. That's what we had that's what we saw just before. So we divide both sides by 4. 4's cancel. We get x is log of 5 over 4. Good. All right. So that's good. Now here's another example I added. Let's get the domain of this here. Now, 4 times x plus 1, right? Well, this alone, if I write y equals, this actually is a polynomial of degree 1. So this has domain equal to all numbers. That's just the inside, though, okay? It's not the domain of f. So 4x plus 1 is defined everywhere. So all we care about is when 4x plus 1 is greater than 0. And again, we just solve this inequality for x. Subtract 1. These cancel. We get 4 times x is bigger than minus 1. Now, dividing by 4. 4's cancel. We get x is greater than negative 1 over 4. So from here, we get minus 1 over 4, comma, infinity. So that's the domain of our